Good day. Today I'm going to show you how to find the equations of the parabola using the derivative or using the gradient of the tangent. There are 4 ways to find the equations of the parabola. The first situation is when you've got one unknown. For instance, in this case, letter A is not known. The second situation is when there are 2 unknowns. In this particular case, for instance, we've got A and B unknown. The third situation is where there are 3 unknowns. For instance, in this case, all A, B, and C are not known. The fourth and final example is where we have to use the derivative or the gradient of the tangent to find the unknown values. In another video, I deal with the first 3 ways. In this particular video, I'm going to deal with how to find the equation of the parabola using the derivative or the gradient of the tangent. If you want to learn the first 3, that video is found right here on the top right of the screen at the suggested video. And if you want the playlist of functions, that playlist is found at the end of this video. So, let's begin. Alright, here is the situation. You are given a parabola and you're told that f passes through 2:6 and the gradient of the tangent to f is -3 when x is equal to 4. Show that a is -half and b is 1. So, first you're given a point, you're given that f passes through this point, and you are told that the gradient of the tangent. What is very important to understand is the gradient of the tangent. So when they tell you the gradient of the tangent, you have to know that first derivative actually represents the gradient of the tangent. So please memorize this, it's very important. Always remember that first derivative always represents the gradient of the tangent. So, first derivative means gradient of the tangent. Let me give you a clear understanding of tangents, then we'll continue. Alright, let me show you a clear understanding of tangents. So, if we draw a tangent right at this point, x is equals to -3, a tangent is a line that touches the graph once, so it's going to look something like this. So, this is going to be the tangent at x is equals to -3. And if we check the gradient of this tangent, this gradient is positive because the graph is increasing from left to right. So if you follow the graph with your fingers moving from left to right, you realize that your finger is going up, so you know that the graph is increasing. But if the graph is decreasing from left to right, then it has got a negative gradient, so the gradient will be negative. But if the graph is increasing from left to right, it will have a positive gradient. So in this case, the gradient can be m is equals to 5 because it's a positive gradient, so I just took any value. So let's just assume that the gradient is positive 5. And then if we draw a tangent at x is equals to -2, it's gonna be a horizontal tangent because it's at a turning point. And if a tangent is horizontal, it means it's neither increasing nor is it decreasing. So we can therefore say that the gradient of this tangent is 0 because it's neither increasing nor decreasing. That is why it's called the stationary point. That is why your turning points are also called the stationary point. That is why whenever you find your turning point or your stationary point, you always say the first derivative is equals to 0. The reason why we say that is because the gradient of the tangent is 0 at the turning point. If we draw another tangent, for instance, let's say at x is equals to -1, it's going to be something like this. So we're going to have a decreasing tangent. So we can assume that the gradient here will be something like -5. So that is what they mean when they say first derivative. First derivative means the gradient at a point. At different points, there are different tangents that can be drawn in the graph. So whenever they say the first derivative, for instance, the first derivative when x is equals to -3, they're saying the gradient of the tangent when x is -3, which would be 5 in this case. If they say the first derivative when x is equals to -2, they're saying what is the gradient of the tangent when x is equals to -2. And we know that this is going to be 0 because it has got a horizontal tangent there. So that's what they mean. First derivative just means the gradient of the tangent. If they say what is the gradient of the tangent, if they say what is the first derivative when x is equals to -1, they're saying what is the gradient of the tangent when x is equals to -1, and that would be -5. So first derivative always represents the gradient of the tangent at that point. Please memorize this, especially those who are my students. Remember, first derivative always represents the gradient of the tangent at that point. Alright, given that understanding, so we are told that f passes through this point. So we have the information that 2 is to 6, and we're told that the gradient of the tangent, which is the first derivative, so we're told that the first derivative is -3. So we're told that the gradient of the tangent, which is the first derivative, is -3 when x is 4. So it means that the gradient of the tangent at 4 is -3, or the gradient of the tangent when x is equals to 4 is -3. So just with these two information, we can begin to solve. So what we're going to do is that we're going to substitute this information into this equation to create the first equation. Then we're going to substitute this information into the derivative of this equation to create the second equation. The reason why we have to substitute it into the derivative is because we're given f prime x, which pertains to the first derivative. So we're going to have to derive this equation and substitute this information to create the second equation. So let's proceed. We're going to deal with substituting this information first. So since the y value is 6, we're going to end up having 6 is equals to a into 2 because our x value is 2. So we're going to have a into 2 squared plus b into 2 plus 6. So we're going to have 6 is equals to 2 squared is 4. So we're going to have 4a plus 2b plus 6. If we take this 6 to the other side, they will cancel out because they're the same. So we'll end up having 0. And then we're going to have 0 is equals to 4a plus 2b. So we can still simplify it further, but I'm going to call it my equation 1. So let's create the second equation by substituting this into the derivative of this. Before substituting this information into the derivative, we need to get the derivative of this equation. So let's get the derivative. So if we derive this equation, we're going to end up having f prime x. So we're going to have f prime x is equals to, when we multiply 2 and a, we're going to have 2ax. And then the derivative of this information will be b. And then this stuff is a constant, it just disappears. So we don't need to care about it. So this is going to be the derivative. So let's substitute this information. So we're told that the answer of the first derivative is -3. So -3 is equals to 2a, and the x value is 4. So we're going to have 2a into 4 plus b. And then we can simplify this equation. So we're going to have -3 is equals to 8a plus b. So I've created my second equation. Alright, so now I've got my two equations. So we can solve these using simultaneous equations. So we can use any method of simultaneous equations. We can use the elimination method, the substitution method, or the equating method. In this case, I'm going to use the substitution method. So I'm going to manipulate my second equation since it's easier to manipulate, and I'm going to make b the subject of the formula. So I'm going to say b is equals to, so when I take 8a to the other side, I'm going to have -8. So this is going to be my third equation. So I'm going to say substitute my third equation into the equation that I did not manipulate, which is the first one. So into equation 1. So meaning I'm going to write the first equation exactly the same. It's just that instead of me writing b, I'm going to write what b is equals to. So it's going to be -3 minus 8a. So let's proceed. I'm going to have 0 is equals to 4a. And then when I distribute these two, it's going to end up being -6 minus 16a. And then when I group this like terms, I'm going to end up having -12a minus 6. So, and then when I take this to the other side, I'm going to have 12a. So I'm going to have 12a is equals to -6. When I divide both sides by 12, I'm going to end up having a is equals to -12. So I got a, just like the question. So let me get b by substituting it into any one of the equations. So I can substitute it into this equation or this equation or this equation. But obviously, the easiest one to substitute is the third one, since b is already the subject of the formula. So I'm going to substitute it into my third equation. So I'm going to say minus 3 minus 8. But instead of me writing a, I'm going to write what a was equals to, which was minus half, is equals to b. So when we simplify this, we're going to have minus 3, and then 8 divided by 2 is 4. Negative times negative is positive. So I'm going to have minus 3 plus 4 is equals to b. Therefore, not minus 1, rather, it's going to be 1 is equals to b. So therefore, I got b as well, just like the question. So my a is equals to negative half, and my b is equals to 1. So there we have it. Let's proceed to the second example. Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvements. Alright, this is another example. So you are given a diagram with F, the parabola, and G, the straight line graph. So you are told that G is a tangent to F at -1 is to 15. So the point of contact of G and F is -1 is to 15. So you are told that G is a tangent to F at this point. Then they said find the values of A and B. What you have to note is that when you're given a tangent, always in functions, whenever you're given a tangent, you have to think about the gradient of the tangent. So what is the gradient of this tangent? So because the gradient of the tangent will represent the first derivative. So we're given the equation of a tangent, which is this. And we want to find the gradient of the tangent. So remember, the straight line graph is always in the form of y is equals to mx plus c. So m is the gradient. So if you have a graph, let's just say y is equals to 2x plus 8. We know that the gradient will be 2 because m is the gradient. Therefore, in this case, the gradient is -1. So we found the gradient of the tangent, which is -1. We can say, therefore, the first derivative is -1. So the first derivative is -1. But the first derivative when x is equals to -1. So the first derivative when x is equals to -1 is -1 because the gradient of the tangent is -1. So we've got this information, and the other information we need is just the point. So we've got a point. So we can use this information twofold. We can use it for the original equation, and we can use it again for the derivative because we know the x value and we already know the gradient of the tangent at this point, which was -1. So therefore, f prime -1 is -1, and we can substitute this information again into the original equation. So let's begin. So let's start by substituting this information. So since the y value is 15, we're going to have 15 is equals to a into, so our x value there is -1. So we're going to have -1 squared plus b into -1 plus 10. So let's simplify this equation. So we're going to have 15 is equals to, this -1 squared is just 1, so we're just going to have b, and then we're going to have, a, then we're going to have a minus b plus 10. If we take this 10 to the other side, we're going to have 15 minus 10, which is just going to be 5. So we're going to have 5 is equals to a minus b, and we can call this our first equation. All right, let me create another equation. So we have to create another equation by using the derivative of this information. So we have to use the derivative. And we have to substitute it into the derivative of this graph because this information pertains to the derivative. So therefore, let's find the derivative. So if we find the derivative, we're going to have f prime x. So we're going to have f prime x is equals to, so when we derive this part, it's just going to be 2ax. So we're going to have 2ax, and then this part is just going to be b. And of course, the constant disappears. So far we've got our derivative. So we can substitute this information. So let me rewrite the equation of the derivative. So then we're going to end up having f prime x. So we're going to have f prime x is equals to 2ax plus b. Alright, so now let's substitute this given information. So we have f prime negative 1 is minus 1, meaning that the answer of the first derivative is minus 1. So therefore we can say minus 1 is equals to 2a, and the x value was just the same as the derivative, it was minus 1. So we're going to have minus 1 plus b. So then this is going to end up being minus 1 is equals to minus 2a plus b. So we've created our second equation. So let's proceed. Alright, so I'm going to use the substitution method, and I'm going to manipulate my second equation and make b the subject of the formula. And therefore I'm going to have b is equals to minus 1. And if I take this minus 2a to the other side, it's going to be plus 2a. So this is going to be my equation 3. Alright, so now I'm going to say substitute equation 3 into equation 1, since I did not manipulate equation 1. So I'm going to write equation 1 exactly the same as it is, but instead of writing b, I'm going to write what b is equals to. So it's going to be minus 1 plus 2a. So let's proceed. Then we continue over here. So I'm going to have 5 is equals to a. When I distribute this negative, this is going to become positive 1 minus 2a. Alright, if I group these like terms, I'm going to end up having a minus 2a, which is minus a. And if I take this 1 to the other side, I'm going to have 5 minus 1, which will be, so I'm going to have 5 minus 1, and this is just going to be 4 is equals to minus 8. Therefore, a is equals to minus 4. So I found a. So let's find b, so we can substitute into any one of the three equations. And when we substitute, so the easiest one to substitute is obviously equation 3, since I've got b as the subject of the formula already. So therefore I'm going to say minus 1 plus 2, but instead of writing a, I'm going to write minus 4 is equals to b. So therefore it's going to be minus 1 minus 8 is equals to b. Therefore b is going to be equals to minus 9. And there we have it. Alright, here is another example. Just before we continue with this example, if you're interested in knowing the prices of the tutorials, the video that contains the prices and the contact details, just in case these ones have changed, is found at the end of this video. So if you're interested in knowing the prices, please watch the video that is found at the end of this video. Alright, here is another example. So you are given a parabola and you're given a straight line graph. And the straight line graph is called G and the parabola is called F. So they say G, which is the straight line graph, is a tangent to F at negative 1 is to 13. Show that A is negative 1 and B is negative 3. So since we're told that this is a tangent, at this point it means that this is the point of contact. So what we need is the gradient of the tangent. So we have got the point of contact, but we need the gradient of the tangent. So we're introduced to an angle. We're not given an equation this time, but this time we're given an angle. And in analytical geometry, we know that whenever we're given the angle, we can use the angle to find the gradient. So this is analytical geometry entering functions. So in analytical geometry, whenever we're given the angle, we find the gradient by using the formula m is equals to tan theta. So therefore it's going to be the gradient is equals to tan 135. And tan 135 is minus 1. The gradient is minus 1, meaning that the first derivative is minus 1 because the gradient of the tangent is minus 1. So therefore we can now say the first derivative when the x value is minus 1 is minus 1. So we have found this information, and combined with this information, we can now solve simultaneously and find the values of a and b. So we have to show them that a is negative 1 and b is negative 3. Let's proceed. So first of all, we have to substitute this information into the original formula. So into the original formula. Alright, let's substitute this information into this equation. So I've already written the equation here. So it means that the y value is 13. Then we're going to have a into the x value is negative 1. So we're going to have negative 1 squared plus b into negative 1 plus 11. So then this is gonna be 13 is equals to -1 squared is just +1. So we're gonna have positive a minus b plus 11. So when we take this 11 to the other side of the equation, we're gonna have 13 minus 11, which is gonna be 2. So 2 is equals to a minus b. So we have created our first equation. So we're gonna substitute this information into the derivative of this graph, since this pertains to the derivative. So we're given that the first derivative when x is -1 is -1. So before we substitute this information, we have to derive this equation. So when we derive this, we get f prime x. So we're going to have f prime x is equals to, when we derive the first part, we get 2ax. Derive the second part, we get plus b. And this part obviously disappears. So let's substitute. So we're given that the answer is -1. So, and the x value is -1. So it's going to be into -1 plus b. So then we're going to have -1 is equals to -2a plus b. So I've created my second equation. So now I'm going to use the substitution method. So I'm going to create my third equation by manipulating the first equation. So I'm going to make, let's just make b the subject of formula by taking it into this side of the equation. So it's going to be b. And then if I take this 2 to the other side of the equation, it's now going to be a minus 2. Alright, I hope that does not confuse you. So if that confuses you, then we can do it like this. We'll just remain with b on this side of the equation. Then we take a to the other side, so it's going to be 2 minus a. But if I switch sides, the signs are going to change, so it's going to be b is equals to -2 plus a. Or we can have b is equals to a minus 2. So a comes this side, it becomes positive, 2 comes this side, it becomes negative. So this is going to be my third equation. Now I can use the substitution formula. So let me use the substitution formula. So therefore I'm going to say substitute equation 3 into the one that I did not manipulate, which was equation 2. This is supposed to be equation 2 and not 1. Alright, so this is equation 2. Alright, so I'm going to write my second equation the same. It's just that wherever I see 2, or rather wherever I see b, I have to replace it with a minus 2. So it means that I will replace it with a minus 2. Then we're going to say -1 is equals to -2a plus a minus 2. So if I take this to the other side, it's going to be -1 plus 2. And then this is going to be minus a. So therefore I'm going to have -1, or rather I'm going to have +1. So this is going to be +1 is equals to minus a. Therefore a is equals to -1, just like the question. And in order to find b, we can substitute into any one of the 3 equations. But obviously the easiest one is the third equation, since b is already the subject of the formula. So therefore I'm going to say b is equals to, instead of writing a, I write -1 minus 2. And therefore b will be equals to -3. And there we have it, just like the question. So b is equals to -3 and a is equals to -1. So let me give you a bonus example. Alright, here is the final example. This question often comes out in functions. So they can give you a tangent to the graph. So they give you a parabola, then they give you a line, and they tell you that G is a tangent to F at point Q. So they give you the tangent. And then they say find Q, the point of contact of F and J. So now we have to find Q. So in this particular case, we're not finding the equation, but we have to find a point of contact. This question actually comes out in the exam. So a lot of people get stuck, especially when they give them a tangent and they give them some angles. So in analytical geometry, we already know that whenever we're given angles, we can use that to find the gradient. And therefore it will be the gradient of the tangent, since this is the tangent. So therefore we can now say the gradient is equals to tan theta. So we'll have tan theta. So we're going to say m is equals to tan 135. So therefore it means m is equals to, we know that tan 35 is minus 1, so we're going to have minus 1. So therefore we found the gradient of the tangent, which is the first derivative, meaning that the first derivative at the x value of q, it's not a must to write it like this, I'm just writing it like this. So the first derivative at the x value of q is equals to minus 1. So you get a mark for that. So this is mathematical notation. So at times we can write, whenever we don't know the value of q, even in trigonometric functions, we can just say the x value of q. And if we're talking about the y value, we can say the y value of q. So the first derivative at the x value of q is negative 1. So now that we've got the information of the first derivative, we still have to find the x value of q and the y value of q. So we have to derive this equation. So we'll derive it, we'll say the first derivative is equals to, this is gonna be 4x minus 17. So we're gonna have 4x minus 17, that's the first derivative. All right, so now we have the answer of the first derivative. We're already told that the first derivative at the x value of q is negative 1. So therefore, we can use that to find the x value of q. So we're going to have minus 4x minus 17. So if we take this to the other side, it's going to be minus 1 plus 17, which is equals to minus 4x. So this is going to be 16 is equals to minus 4x. And therefore we're going to find x. So it means that when I divide both sides by negative 4, I'm going to end up having negative 4 is equals to x. So we found x. So the x value of q is negative 4. So now we need to find the y value of q. All right, so we're going to substitute the x value of q into this formula so that we can have the y value. All right, so let's substitute the x value of q. So I have rewritten the equation over here. So the x value of q is minus 4, so we can use that to find the y value. So it's going to be f of minus 4 is equals to minus 2 into minus 4 squared minus 17 into minus 4 plus 9. So therefore we're going to have the y value or f at minus 4, we're going to have f at minus 4 is equals to, so minus 4 squared is 16 times minus 2 is negative 32. And then this part is going to be 17 times 4 is the same as 40 plus 28, which is 68. So we're going to have 68 plus 9. So now we can simplify this stuff. So then it's going to be minus 32 plus 68, which is going to be, I know that 8 minus 2 is 6, and 6 minus 60 minus 30 is 30. So it's going to be 36 plus 9. So 36 plus 9, which is 45. You can verify that with me. So this is going to be 45. So we found the y value when x is equals to negative 4. So we have found the point of contact. Therefore, we can say q is negative 4 is to 45. And there we have it. So if you enjoyed this video, please like my video and subscribe to my channel. And if any of the contacts are not working, or if you have any questions, please comment below.